So we'll be talking about exploring energy conservation with a system of balls. So just to introduce the experiment, our experiment covers potential and kinetic energy, and we use different size balls, in this case a basketball and a racquetball. We balance these balls separately and then together to find if we could see the potential and kinetic energy of the balls, and we could use these to predict the height of the ball and then compare this to the experimental height that we recorded. We also use this data to explore the differences in the height due to a conservation of energy. Just to kind of show and give a little introduction, potential energy, as you can see, is when you're at the top of something or when you're not moving, and that's why the equation of potential energy is mgh, so your mass, your gravity, and then the height. Kinetic energy is when you are moving, so you can see the diagram when the biker is going down the slope, and the energy is in the equation, is 1/2 mv squared. So our hypothesis is that if the height of the bounce of the basketball is calculated, then the height of the bounce, when you include the racquetball on top, so in this case we have the system of balls and the racquetballs on top, this height will be lower, but the total energy of the system is still conserved. And so the reason why the height will be lower is because some of the kinetic energy from the basketball will be transferred to the racquetball when the bounce happens, but the total kinetic energy is still conserved. So when you add the basketball and racquetball's kinetic energy, it should be equal to just the basketball when it was dropped separately. So as you can see, here's the first video, which is just the basketball being dropped.
Go. Go.
And so we included the data for the basketball. So when we predicted the height for the basketball, they came out to about 2.99 feet. And the expected value, which is what we determined from the graphical analysis, was 2.91. So obviously very close. Also included the graph on the side that shows the height in blue and the velocity in green, which is what we used to find the height. And the equation we use is mgh equals 1/2 mv squared. So we basically set the potential energy equal to the kinetic energy. Now here's a video of the basketball and the racquetball on top of the basketball. So this is what we predicted to be a lower height. So as you can see, when we did this with the basketball and the racquetball on top, the height turned out to be 2.14 feet as opposed to 2.99 feet. So the height did reduce, and the expected height was 2.147 feet. So basically the same number. And once again, we included this graph on the right. We also did the racquetball and the basketball to find the height of the racquetball, and the height came out to 15.73 feet. The expected was 16.23 feet. This was a little bit more off, but still very close when you consider that these numbers are higher than the other numbers. So now we wanted to prove that the energy in the system, because this was an isolated system and while we did it, was still conserved. Because basically we found that when the basketball bounced on its own, the height was 2.99 feet. But when the basketball bounced the racquetball on top, the height was 2.19 feet. So we figured, where is this energy going? And we wanted to prove that through setting the kinetic energy of just the basketball equal to the kinetic energy of the basketball and the racquetball combined. So as we can see, we just did a 1/2 mv squared for the whole thing, set them equal to each other. The 0.625 is the mass of the basketball, the 0.04 is the mass of the racquetball, the 2.43 is the meters per second, the velocity of the actual basketball, and the 1.98 is the velocity of the basketball when the racquetball is included, and the 5.3 is the velocity of the racquetball. And as you can see, the kinetic energy in joules was about the same. 1.84 is about equal to 1.80. So through this, we proved that even though the basketball lost height when the racquetball was on top, the energy of the system was still contained